Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. In today's class we will see an experiment based on CPU registers, which is a subtractor. Okay, so this is experiment number 9. So the aim and objective of this experiment is to examine arithmetic circuits that add and subtract the numbers. Each circuit will be described in the Verilog programming language and it will be executed on the Altera kit. Okay, so after the experiment is over in the software, we will see how the experiment is being executed in the hardware. Okay, so here this is the block diagram for your 4-bit ripple carry adder. Okay, we have seen this quite a few times in our lab experiments, and this is an 8-bit accumulator circuit. Okay, so this circuit will be implemented for a adder as well as a subtractor. The steps what you have to do here is we have to design and compile our circuit using the Quartus 2 software, which you have downloaded in your previous lab experiment, and we have to test it on the Altera kit. So in this, the first step is to create a Quartus project, which all of you are familiar with. Okay, you have to select the target chip, which we know is EP4 CE115F29C7. Okay, you have to select the target chip and then implement the designed circuit on the DE2 kit. Next, we have to write a Verilog program language. Okay, we have to write a program to implement our circuit, which is given in figure 2. Okay, so the circuit, what it describes here is A has 8 inputs over here. Okay, this has 8 inputs. So what we will do, we will connect input A to switches 0 to 7 to 8, 0 to 7, which is 8 switches. Okay, and then we will use key 0 as a reset. Key 0 we will use it as reset, and next we will use key 1 as a clock. Okay, so switches 0 to 7 we will use for input A, and then key 0 we will use it for reset, and key 1 we will use it for a clock. The output, the sum output, is displayed on red LED R 0 to 7. The output is displayed on LED lights, and carry out is displayed in red LED R 8. Okay, so the output is displayed in the red LED R 0 to 7, and the carry out is displayed on red LED R 8. Next, after we give the inputs and outputs, we have to assign the pins on the FPGA to connect to the switches and 7 segment displays. Okay, by using the pin assignment file, which is already there in the blackboard. So use the pin assignment file to assign the pin numbers. Okay, next you have to compile your program and execute it on the kit. If it is without any errors, okay, and the simulation is working properly, you have to download the circuit or the program onto the kit and test it by using different values of A. Okay, next we open the Quartus 2 compilation report and examine the results reported by the timing analyzer. Okay, so here this is your program. It is already given here what are your inputs and outputs. Okay, if you see the inputs and outputs, switch 0 to 7 is connected to input A. Switch 16 is telling you whether to add or to subtract. Okay, if it is 0 it is addition, and if it is 1 it is subtraction, and so on. Key 0 it is a reset. Key 1 is your clock. Okay, LED R 0 to 7 gives you the sum, okay, in the binary form. This is in your binary form. In the hexadecimal 6 and 7, okay, hexadecimal 6 display and hexadecimal 7 display, you get the output for your A, input A, okay, and hex 4 and 5 shows the input B, okay. Next, hex 0 to 3 shows you the output for the sum. Next, LED G8 shows if there is any overflow. And then this is your program for your adder and subtractor, okay. I have already used this program and I have already started the project, okay. So we will see how to compile and execute this in your software. So first step, as you see here, we have to create a project. So you go to Quartus, okay, web edition, and then you select create a new project, click next, select browse and create a new folder, give the name for your project. If it is part 2, or you can give whatever name you want, you can give subtract, okay. Next, choose this. In the file what I have created, I've used the name as part 2, okay, and use the same name here as subtract, click next. In step 2 you should not do anything. Go to step 3, select, close this, go to step 3, select cyclone 4E and go to the last, select your pin number. Next, step 4, don't do anything, go to next, check everything if it is working fine and all the details are entered correctly, click finish. Next you have to go to file, select new, Verilog HDL, click OK, and you are ready to type your program, okay. So here I have already typed my program, okay. The program is ready over here and I have given the name as part 2, okay. So after you have typed your program, what you have to do, you have to compile your program and check if there are any errors. So here you will see the compilation process. If it is 100%, once this becomes 100%, you have to enter your pin numbers using the pin planner. So wait until all these become 100%, reach 100%, and then you can go to your pin planner to enter your pin numbers. So click OK. When the compilation was successful, go to assignments, select pin planner. So I have entered your pin numbers here, okay. So you also enter your pin numbers and then you can minimize or close this and then compile again, okay, to check the result on your FPGA device, okay. So here now the compilation is successful, so I'll click OK. Next, what we have to do is we have to load the experiment in our hardware device to see the result, okay. So now once the program is successfully compiled, you have to load it into your device. So go to tools, programmer, and see if this is in USB and then click start, okay. If this USB is not showing it for you, go to hardware setup, it will show you USB. So double click on this, click close, okay. So once the USB blaster is visible to you over here, you can click start. So once this progress bar reaches 100%, your program is loaded into the kit. So now we will check the result on the kit. Okay, so now coming to the end of the experiment, and to check the result, we will see how once the program is loaded, we will see how to see the result. So here key 0 is used for your reset. Key 1 is used for the clock. Okay, and switch 0 to switch 7, 8 pins, we will use it for the input. Okay, now switch 16 over here, we will use it for the addition or subtraction. When this is 0, it is performing addition. When switch 16 is 1, it is performing subtraction. Okay, so first we will see the addition part now. So first I will give switch 0, I will change it to 1. Okay, so now this should be entered into the processor. So I'll press clock, and you can see the result now. It is entering the now it is entering into the computer. So when I press clock, the processor is taking the input and it is changing to 1. Now when I press clock for the second time, this 1 is added to the data in the accumulator. So data is 0. So 1 plus 0, it becomes 1. So I press clock one more time and it changes to 1. So you see the result here in the binary, in the LED, and the hexadecimal digit, you can see it in the display, hexadecimal display, hex 0. So now if I press clock again, it changes. 1 plus 1 becomes 2. 2 plus 1 becomes 3. And similarly, you can see the result over here also in the binary. Okay, 3 plus 1, 4, 5, 6, etc. So now if I change this switch 16 to 1, it becomes subtractor now. So when I press clock, it should become 6 minus 1, it should become 5. 5 minus 1, 4. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1. Now when I press key 0, everything should become 0. It is reset. Key 0 is reset. So now it is back to, everything is back to 0. So this is your experiment for adder and subtractor using an accumulator register. Okay, so that is all for experiment 9. Thank you. See you in the next lecture, inshallah.